Hello everyone. In today's session, we will discuss about one of the particle accelerator, that is Cyclotron Accelerator, which is the example for the second type of accelerator, that is cyclic accelerator. So in this session, we will discuss about its principle, construction and working, and after that we will discuss about in brief the advantages and limitations of this cyclotron accelerator. The cyclotron accelerator is nothing but a particle accelerator which accelerates the charged particles outwards from the center along a spiral path. So it can accelerate the charged particles outwards from the center, which is moving along a spiral path or the circular path. The particles are held to a spiral trajectory with the help of the static magnetic field. So the movement of these particles held to a spiral trajectory by applying a certain static magnetic field, and these particles can be accelerated by a rapidly varying electric field. So this rapidly varying electric field can be achievable with the help of the radio frequency generator. So this is the cyclotron accelerator, which accelerates the charged particle outwards from the center along a spiral path. So if you look at the construction of this cyclotron accelerator, it consists of two electrodes, and the shape of these two electrodes is similar to the English alphabet D. That's why these two electrodes are called as Ds. So in this diagram, these two electrodes or these two Ds are denoted by two different colors. One is in blue color and another one is in red color. So these are the two electrodes. So in between these two electrodes there is an ion source which can emit, or from that ion source we can extract the ions, and those ions can be accelerated within the gap between these two electrodes with the help of the radio frequency generator. And at last, after moving in a spiral trajectory or path, at the periphery, means at the outer surface of these two electrodes, that is two Ds, we can extract high energy charged particle with the help of deflection magnet towards the target in the experimental chamber. So this is the construction of this cyclotron accelerator. The basic operating principle of a cyclotron is that the particles are accelerated in spiral paths inside two semicircular flat metallic electrodes called Ds. So why they have been called as Ds? Because the shape of those two electrodes is in resemblance with the English alphabet D. So they are similar to that letter D. That's why they have been called as Ds. So the basic principle of this cyclotron accelerator is the particles are accelerated in a spiral path inside the two semicircular flat metallic electrodes called Ds. Then the Ds are connected to an RF generator, that is radio frequency generator. It is used to generate the rapidly varying electric field so that we can accelerate the charged particles. So the Ds are connected to an radio frequency generator and are placed in a nearly uniform magnetic field. The charged particles are produced by an ion source which is located at the center of the cyclotron between the two Ds. So in between the two Ds, the ion source is placed, and from that ion source we can extract the charged particles. So these charged particles are accelerated in between those two D's. So before that, these charged particles are extracted from the ion source for the acceleration purpose by a fuller electrode at the same potential as the D. So there is an electrode which can extract the charged particles or ions from the ion source, which is located at the center in between these two D's with the help of certain electrode, and this electrode is operating at the same potential as the two D's are operating. The magnetic field causes the particle to move in a plane called median plane in approximately circular orbits inside the D and across the gap between them. So why the magnetic field has been applied to this cyclotron accelerator or these two D's? So this magnetic field helps the charged particles to move in a circular orbits inside those two D's and across the gap between them. In that gap only these charged particles are accelerated. At each gap, particles are accelerated and therefore they follow a spiral path as they gain energy. So at each gap, means gap between the two D's, the particles will be accelerated. So because of that acceleration, the velocity is increasing, means velocity is increasing means then only we can say that the charged particles are accelerated. So because of increase in velocity, the energy also increases because the kinetic energy is given by the expression half mv square. So energy is directly proportional to velocity. So velocity increases means the energy is also increasing. So at each gap the particles are accelerated and therefore they follow a spiral path as they gain energy. This is because the radius of orbit being a function of the particle velocity which increases with the time. So velocity increases, we can say that the particles are accelerated. Because of increment in velocity, the energy also increases. So at the edge of the magnet, full energy particle beam is pulled out or extracted as an external beam by an electrostatic deflector. So at the edge of the magnet or at the periphery of these two D's, the high energy particle can be extracted for the experimental purpose with the help of deflection magnet or the electrostatic deflector. The D's, the deflector, ion source, etc. are enclosed in a flat vacuum chamber where a low pressure of the order of 10 raised to minus 6 torr is maintained. So all these materials, that is two electrodes D's, the deflector which helps to extract the high energy beam, and after that the ion source which is located at the center between these two D's, all these materials are enclosed in a flat vacuum chamber where a low pressure of the order of 10 raised to minus 6 torr is maintained. So why this low pressure or high vacuum is required? So this high vacuum is essential to generate high voltages on D's and deflector, as well as to avoid the beam loss by scattering during acceleration. So in order to avoid the beam loss by the scattering phenomenon and to generate high voltage on the two electrodes, that is two D's and the deflector, all these equipments are placed in a high vacuum. So that purpose this high vacuum is essential. So if the particle speeds were constant, they would travel in a circular path within the D's under the influence of the magnetic field. So if the speed of the particle is constant, then they will travel along a circular path within those two electrodes under the influence of the magnetic field. However, a radio frequency alternating voltage of several thousand volts is applied between the Ds. So if the particle velocity or speed is constant, they will travel in the circular path under the influence of the magnetic field. But there is a radio frequency alternating voltage which is of the order of several thousand volts is applied between the two electrodes. This voltage creates an oscillating electric field in the gap between the Ds, and that oscillating electric field accelerates the particles. So this alternating radio frequency voltage is responsible for the acceleration of the charged particles. The frequency, that is radio frequency generator, the frequency of that is set so that the particles make one circuit along a single cycle of the voltage. So in that order the frequency is set. So to achieve this condition, means for the acceleration purpose, we are applying the radio frequency alternating voltage. So to achieve this, the frequency must match the particle's cyclotron resonance frequency. So the frequency of that radio frequency generator must be equal to the particle's cyclotron resonance frequency, which is given by the formula F is equal to Q into B divided by 2 pi M, where B is the magnetic field strength, Q is the electric charge of the particle, and M is the mass of that charged particle. So each time after the particle pass to the other D electrode, the polarity of the radio frequency voltage reverses. Therefore, each time the particle cross the gap from one D electrode to the other, the electric field is in the correct direction to accelerate the charged particles. So when the charged particles moves from one D electrode to other D electrode, there will be reverse in the radio frequency voltage. So because of that, the current is in the possible correct direction to accelerate those charged particles in between the gap of the two Ds. The particles increasing speed due to these pushes causes them to move in a larger radius circle with each rotation, so that the particle moves in a spiral path outward from the center to the rim of the disk. So because of this reverse in radio frequency voltage, which is responsible for accelerating these charged particles, so these charged particles achieves the higher speed, means there will be increment in the speed of those charged particles, and because of that increased speed, these particles moves in a larger radius circle with each rotation, so that these particles moves in a spiral path outward from the center towards the rim of the disk, means towards the outer surface of those two electrodes. Then what is the energy of the particles which can be extracted from this cyclotron accelerator? So as we have discussed now, because of the acceleration there will be increase in velocity, means because of the increase in velocity we can say that the charged particles are accelerated, and because of that there will be increase in energy. So how this energy is dependent on other parameter? So that is the particle energy. Since the particles are accelerated by the voltage many times, the final energy of the particles is not dependent on the accelerating voltage, but on the strength of the magnetic field and the diameter of the accelerating chamber. So in this cyclotron accelerator, the accelerating chamber is the Ds, that is 2 electrodes Ds. So the particle energy which we can, and the particles which can be extracted from the cyclotron accelerator, its energy is dependent only on the strength of the magnetic field and the diameter of the accelerating chamber, that is the 2 Ds, and it is not dependent on the accelerating voltage. So we will derive the relation for that. Means the energy is dependent only on the strength of the magnetic field B and the diameter or the radius of the accelerating chamber, that is the 2 Ds. Cyclotrons can only accelerate particles to speeds much slower than the speed of the light, that is non-relativistic speed. So we can call this as the one of the limitation of this cyclotron accelerator. Means it can accelerate the charged particles to speeds much slower than the speed of the light. Means few percent of the speed of light can be achieved for the particle acceleration in the case of cyclotron accelerator. So for non-relativistic particles, the centrifugal force Fc required to keep them in their curved path is Fc is equal to mv square by r. So this is the general expression for centrifugal force, which is responsible for keeping those charged particles in the circular path. So that force is equal to mv square by r, where m is the mass of the particle, v is the velocity with which they are moving, and r is the radius of the path. Then apart from this centrifugal force, there is one more force, Lorentz force Fb, due to that applying of the magnetic field, and this centrifugal force is provided by Lorentz force Fb of the magnetic field B. So that Lorentz force Fb is equal to qvb, where q is the charge of the particle, v is the velocity, and again b is the strength of the magnetic field. So the particles reach their maximum energy at the periphery of the Ds, where the radius of their path is small r, that is radius of the path of the particles, is equal to that capital R, that is the radius of the Ds. So the particles can achieve their maximum energy at the outer surface of the Ds, almost at the edge, that is the periphery of the Ds. So at that outer surface, the radius of the path of the charged particle is equal to the radius of the Ds. So that is that small r, which is radius of the path of the charged particle, is equal to the capital R, that is the radius of the Ds. Then we can equate these two forces, that is centrifugal force and the Lorentz force of the magnetic field. So by equating these two, we get mv square by r is equal to qvb. So 1v gets cancelled. So the final expression for velocity v is equal to qbr divided by m. So just by rearranging the terms, we can get this equation for velocity, that is v is equal to qbr by m. So the output energy of the particle which can be extracted from the cyclotron accelerator is energy is equal to half mv square. So we can substitute v here, so that the energy equation becomes q square b square r square divided by 2m. So we can substitute v is equal to qbr divided by m, then square of that quantity is q square b square r square divided by m square. Then as we have 1 by 2 m as the multiplication term, so 1 m gets cancelled. At last we left with the output energy of the particle is equal to q square b square r square divided by 2m. So from this expression we can say that the energy of the charged particles is dependent on B, that is strength of the magnetic field, and R is the radius of the accelerating chamber, that is d. Therefore, the limit to the cyclotron's output energy for a given type of particle is the strength of the magnetic field and the radius of the D's, which is determined by the diameter of the magnet's 4 pieces. So, at last we can say that the maximum energy we can extract of the charged particle from the cyclotron accelerator is dependent on the strength of the magnetic field as well as the radius of the acceleration chamber, that is D's, but it is independent on the accelerating voltage. So by using such cyclic accelerator, that is cyclotron accelerator, we can extract high energy charged particle to the experimental station depending upon our experimental requirements. So this is the principal construction, working and the maximum energy of the charged particle which can be extracted from the cyclotron accelerator. Then, like many other scientific instruments, this cyclotron accelerator has certain advantages as well as disadvantages or the limitations. So what are the advantages of this cyclotron accelerator? Means the LINAC, which we have discussed in our earlier session, that is linear accelerator. So using such a linear accelerator, it is not possible to generate high power, high frequency radio waves. So using linear accelerators, it is not possible to generate high power, high frequency radio waves. Why it is possible? Because the generation of such high power, high frequency radio waves using LINACs requires the long structure of the linear accelerator. So it is not possible to generate such high power, high frequency radio waves. But the compactness, means the reduction in size of this cyclotron, reduces other costs as well. So what are the other costs? Such as the foundations, radiation shielding and the enclosing building. So using this cyclotron accelerator, we can generate high power, high frequency radio waves which cannot be possible using the linear accelerator. So cyclotrons have a single electrical driver which saves both money as well as power. Furthermore, cyclotrons are able to produce a continuous beam of particles at the target in the experimental station, so that the average power passed from particle beam into a target is relatively high. So these are some of the advantages of this cyclotron. So the first one is we can generate the high power, high frequency radio waves using the cyclotron accelerator. So this can be achieved with the help of the compactness of the cyclotron, which reduces the other costs such as foundation, radiation shielding and the enclosing building. And this cyclotron accelerator have a single electrical driver, so it can save both money as well as power. Along with this, the cyclotrons are able to produce a continuous beam of particles at the target, so that average power passed from a particle beam into a target is relatively high. But as we have discussed earlier, this cyclotron accelerator can accelerate the charged particles to a few percent of that velocity of light. So that is one of the limitation. So limitations of this cyclotron accelerator are: if the particle becomes fast enough that relativistic effects become important, that is, the beam becomes out of phase with the oscillating electric field and cannot receive any additional acceleration. Means if the velocity of particle is equal to velocity of light, then that particle becomes out of phase. That's why we cannot accelerate or we cannot increase the velocity of the particles using this cyclotron accelerator. The classical cyclotron is therefore only capable of accelerating particles up to a few percent of the speed of light. So that is one of the limitation of this cyclotron accelerator. Using such accelerator, we can accelerate the particles up to the few percent of the speed of light. So with this, in today's session, we have discussed about the principle, construction, working, the energy, output energy of the particles from that cyclotron accelerator, and at last its advantages and limitations. So with this nuclear physics unit is completed. In brief, if we want to recall all the discussions which we had in these sessions. So initially we have discussed about the theory of alpha decay, range, ionization and specific ionization of alpha decay, and the Geiger-Nuttall relation. So that is about alpha decay. Then in the second part, that is beta rays, we have the continuous beta spectrum and the neutrino hypothesis. So that is the second part about beta decay or the beta rays. In the third section, we have the discussion on the nuclear models. So in that we have discussed the liquid drop model, in that the concept of binding energy, semi-empirical mass formula, then explanation of nuclear fission on the basis of the liquid drop model, and at last the nuclear shell model and the explanation of the stability of the nucleus on the basis of the magic numbers. So that is the third section, which is about nuclear models. And at last, in the last part of this chapter, that is nuclear instruments, we have the discussion on the detectors and the accelerators. So in the detectors, we have discussed about the GM counter, that is Geiger-Müller counter, and the scintillation counter. And in the accelerator part, we have discussed about the linear accelerator, and in today's session the cyclotron accelerator. So in brief, this is the syllabus, which is this is the syllabus of this third chapter, that is the nuclear physics. So in the next 1 or 2 sessions, we will solve some of the problems based on this linear accelerator or this cyclotron accelerator resonance frequency, then the calculation of binding energy, then the different types of radioactivity, that is alpha decay and beta decay. So we will solve some of the problems on these concepts in the next session. Thank you.